Good evening, everybody. Thank you for coming. It's very special to be presenting here today, of course, the home, the shrine of British science and technology since the early part of the Industrial Revolution. And somewhat daringly, that's what I'd like to talk about today. So this place was founded in 1799 to promote British science and technology, very much cognizant of its continental rivals, Germany and France. And I think it's done, we can say, a very an amazing job, a magical job of fulfilling that mission. And I'd first like to start there on the legacy. So some of the outputs of the activity here, and there are too many to mention. We actually have a couple of physical examples here. So we have the Humphrey Davy's original version 1 miner's safety lamp from 1815. I'll be saying more about that in a moment. We have Dewar's original vacuum flask from his cryogenic research. So it's basically two containers, and they're separated by a partial vacuum to keep the liquid gases very, very cold, and many others, some of which are shown in the slide. So that object on the left is the ring transformer by Michael Faraday. We also have, don't have a picture of it, but Faraday's so-called electric rotation apparatus. The electrical motor was invented here. William Bragg's ionizing spectrometer in the middle there. The first sample of benzene to be isolated, and many other inventions. These things apparently come out of nothing. A genius mind comes up with a solution to a problem, or something we didn't even know was a problem. And I'd like to talk about how this magical process of innovation, bringing new things to the world, actually works. What's my qualification for doing so? Well, I've studied digital innovation a lot, the latest wave of innovation since the 1980s that has shaped the information world, and written a book about that, which I'll be talking about. And I think my co-author is here this evening, Bob Goodson. Bob, just there, was one of the critical people in the development of social media, Web 2.0. I'm also privileged to be a trustee of LIMS, the London Institute of Mathematical Sciences, which is based upstairs, which does some wonderful pure and applied mathematical research, and I'll say something about that too. So let's start with a heroic story. So here's Sir Humphrey Davy, chemist, a great inventor. And one of his inventions was the miner's safety lamp. It's a very, very simple device, but it solved an enormous problem. So in 1815, he receives a call from the Reverend Robert Gray from Bishop's Wearmouth in County Durham. And this is following a very major mine incident, a major explosion in a mine. And explosions, methane explosions, fire damp explosions are very common. We're not only killing lots of miners, but also derailing the Industrial Revolution, literally disrupting coal supply, which was the fuel source for the Industrial Revolution. And so this was in 1815. Within weeks, Sir Humphrey was busy at inventing a solution, and he very quickly, in the latter part of the year, working over a 3-month period, the last 3 months of 1815, came up with the idea that a gauze, you can see this copper gauze here, inexpensive, would stop the flame from propagating outside of the container, because it would essentially lower the temperature of the gases below their ignition point. So even though the flame was in contact with methane, there would be no explosion. He was testing it very quickly. Within 3 months, he was testing it in mines in the northern part of England. He solved the problem. Coal production was resumed. He didn't make a lot of money out of the invention, but he won a £2,000 prize and much recognition. And the story is told in, I think, every primary school across the land about how Sir Humphrey Davy essentially saved the Industrial Revolution. And it may be a familiar story. How many of you have heard this story? You probably either heard the story or heard something like the story. I heard about it at primary school, and I heard about Edison and other great inventors. And these hero stories of scientific innovation are very common, and they follow a pattern. The pattern is usually some very celebrated individual, often celebrated as a genius or a very ingenious person, usually a man in the times of the Industrial Revolution. Usually they have a very intentionality is another characteristic of these stories. So we tell the story as if the problem was very clear, the strategy was very clear, the principle being deployed was very clear, the process was very clear and intentional, and the invention, the eventual safety lamp, was precisely as intended. It solved a known problem as intended. It's usually an instantaneous or a very rapid story. When children ask the question, who, there is an answer. And when they ask when, we're usually able to give the year. So it's a very rapid process. And the Humphrey Davy story has that characteristic, right? Within weeks, he'd created the prototype, and within months, he'd tested the prototype. And a few months later, he was rolling out the invention. Also often, but not always, isolation is another characteristic, that the invention doesn't actually take place in the coal mine. It takes place in the laboratory or the Royal Institution, one step removed from daily reality, and then is imported into daily reality. And many other stories like that, of course. Most of the inventions that shape the modern world, if you mentally tick down the list of inventions that have shaped your life, everything from the telephone to the iPhone, we usually associate them with an iconic individual and a story that takes place in a very small amount of time, and a story about how they very intentionally solved a problem. Heroic narratives. We love the heroic narratives. Some scientists have said that scientists don't always tell it as it was, though. So that's the story as it's told. Post-doc, the question is that what actually happened? And I'd like to delve into that a little bit this evening. So let's talk about a very different story, one that Bob and I spent 3 years thinking about. And actually, this is a sketch by Bob that he made as employee number 1 of the digital company Yelp in 2005. And you can see pretty clearly that it looks pretty much like a like button. There's a thumbs up sketch and a thumbs down sketch and a counter and some notes on how it would be used. And I just by serendipity, Bob and I got talking about, we were just getting to know each other. We hardly knew each other, and we were getting to know each other, and we just stumbled. Fortunately, Bob was moving, so he was repacking his stuff into boxes, and so we talked about the stuff that he was stumbling across, his memories, mementos, and we chanced upon this page. And it presented a question to us. So my question to Bob was, are you telling me that you invented the like button? Because the date that I associated with the like button was Facebook's rollout of, Facebook was the hero in my mind, rolled out the like button and social media in 2009. And Bob's reply was very curious. He didn't say yes, he didn't say no. He said, no, of course not, well, maybe. Now, I can understand if Bob had invented the like button or not invented the like button, but what I couldn't understand was whether he didn't know whether he'd invented the like button. So we'd intended to meet for 30 minutes. The meeting actually turned into a 12-hour meeting. And by the end of it, we didn't know who invented the like button, but we felt like we had a very interesting and winding story about how the like button came about. So who did invent the like button? Well, after 3 years' research, it's really hard to say unless you draw a very arbitrary line, because in some sense it was it looks like some of you are old enough to remember digital bulletin boards. You could get these digital bulletin boards on your TV in the UK, or Minitel in France, where one of the functions they had was a digital voting function. So in a sense, that's what the like button is. So the bulletin boards of the early 1990s, in a sense, were a sort of form of voting mechanism that was equivalent to the like button. There was actually a physical like button on the TiVo controller. If you remember one of the most user-unfriendly inventions in human history, the VCR. Remember trying to program your VCRs? Very, very difficult. My engineering friends couldn't figure out how to program their VCRs. And that was an opportunity for TiVo to create the so-called peanut controller that had physical buttons, the red and the green button you can see there, which had a little thumbs up and thumbs down symbol on them. And if you pressed a program that you liked, the idea would be that you didn't have to program the time and the channel into the VCR. The software would learn what you liked and then give you more of what you liked. So that was a physical like button, and it involved software. Is that the like button? Well, not quite. This was the early days of user content creation. So there were lots of sites like Everything2 and Dig, where you could submit a link to some interesting content or vote on a link, vote the link up or vote it down. So in a sense, this is user preference gathering on user-generated content. So is that a like button? It's getting closer. It has a certain similarity to the like button. We have the first instant voting button for this slightly salacious site, Hot or Not. If you remember Hot or Not in your younger years, you voted on whether your acquaintances were hot or not. And that was actually a very interesting technical challenge, because in the days of dial-up internet, your vote could have disconnected your service or taken 2 minutes to give you the results. So that wasn't a very effective form of engagement. So we needed some way of solving the programming problem of getting an instant reaction in the world of dial-up. And the site Hot or Not, James Hong solved for that problem. We have Bob's company. So Bob drew in the sketch that brought us together, drew a thumbs up and a thumbs down symbol. Actually, the company decided to go a slightly different way. It went with a threefold symbol of useful, funny, and cool, but in a sense, it was the first emotional aggregation and reaction button that had instantaneous effect on the internet, and including the three symbols you see there. And eventually we get to Facebook, that actually opposed the introduction of the like button for many years, and didn't have the plan for the like button as it played out in the rise of social media. So who invented the like button? I think the hero story would say, my friend Bob is a hero, Bob did. But unfortunately, it's not quite true. There are many fathers and mothers here, and it's very hard to draw the line. And this is a simplified summary, by the way. So let's talk about why the like button was invented and how it was invented. So the key problem here is that you have the nuclear winter of after the dot bomb event, where essentially everyone in Silicon Valley went back to their day jobs around the year 2000, and you had a couple of visionaries who said basically there'll be a next wave. It came to be called Web 2.0. And the idea was that the web as it was before 2000, essentially a big bulletin board for one-way communication of essentially pamphlets to consumers. Here's a piece of information, here's a piece of information. The idea was that it could be two-way. But there was a massive technical problem with two-way communication with consumers because we couldn't get the reaction to the server and back fast enough with the modems at the time. So this was a 56K modem. You can't do a lot at 56K. And so essentially, the people that stayed in Silicon Valley were all confronted with different variants of a technical problem, which is, so how can you carry out these reactions and this feedback, aggregate this feedback, if you can't actually send signals back and forth to the server? And the solution that many people stumbled across during the period was to carry out the computation, the reaction, in the browser itself. with JavaScript, a purpose for which the language was not originally intended. So don't send the signals back to the server to be computed, do them locally in the browser. And many people were doing variants of this, and they were all sharing information, which makes it hard to understand who actually did this first. One of the really interesting things about speaking to pretty much every pioneer that was working on some variant of that problem is that it was a tricky conversation to have because none of them were aware of the eventual consequences of the like button. They were just literally trying to solve the tactical problem of the day, which on a particular day happened to be, how can I record a reaction from a user? But the next day, there was another technical problem, and the next day, there was another technical problem. So not only was there no foresight in the eventual power of the like button, and it did actually change the entire digital world, right? The like button was the monetization mechanism for Web 2.0, for an interactive web, because without being able to target advertising precisely using data from the like button, really it would have been a hobby and not a business. It ushered in the disruption of digital advertising. It changed how my children communicate and affiliate and recognize and transact and create, of course. They're often assessing each other's creations online, as well as a host of negative social side effects. So really a very tiny thing, a dozen lines of JavaScript code had an enormous impact. But that was not the problem that the pioneers were solving. They were solving far more tactical problems. And not only that, but there was no sense that the day in which they made their contribution was special in any way. It was just a day as an engineer solving a tactical problem. So the first part of our interview was always encouraging them, reminding them about that contribution and helping them to remember that day, because it wasn't an especially important day. The eventual consequences emerged from all of this tactical activity. We did find one person that pretty much foresaw the shape of the social media revolution, but it was actually not a technologist. It was a writer, a science fiction writer, Gary Steingart. He wrote a novel called Super Sad True Love Story, and he pretty much predicted, it's a dystopian novel about a world where young people live primarily online, and they appreciate each other and they appreciate culture primarily by scoring things. Everything is scored. And he wrote it a little darkly, but pretty much as it played out. And so we were very curious. How come none of the technologists saw this, and how come you could see this? And his answer was sort of threefold. He said, well, I was lucky. You know, as a writer, I have to entertain, I have to write interesting things, and this seemed to me to be an interesting scenario. But he said it wasn't a shot in the dark. He said he believed that, and it's a formula he's used in some of his other novels, if he goes to the edge of the current reality, for instance, the very early adopters of social media, he can see the future in the present. So he said basically he signed up for all of the accounts to all of the minor social media business. He immersed himself in it, and he asked, if this became a thing, what would that thing look like? And then his second trick was, he said, you know, the technologists have got an enormous blind spot. And that blind spot is they're interested in technology. So while the technologists were asking the question, what can the technology do? He was asking a different question. He was saying, if the technology does what it's supposed to do, what would the humans do with it? And his answer was quite simple, which is, with his knowledge of humanity, the humans would do all of the human behavioral suite with this technology. They would deceive, they would boast, they would disseminate, they would flatter, they'd be treacherous. They would play all of the games with the technology, not just the intended game, and that sort of pretty much turned out to be the way it was. So let's ask our second, you know, we've asked our first naive, childish question, which is who invented the like button? When was the like button invented? Well, since it's hard to say who, it becomes hard to say when. But the hand gestures, of course, are ancient. We are wired to be obsessed by hands, our agency, and faces, our identity. So babies spend a lot of their time looking at faces and hands. And if we go back into history, we find gestural language may have probably preceded any other form of language. And so we spent a lot of time with Professor Christakis at Yale, a social psychologist, who basically explained to us that the like button was tapping into a very hardwired set of evolved behaviors, which are actually the unique superpower of our species. So he believes that the superpower of our species, the distinguishing characteristic, is social learning. So ordinarily, animals, organisms, they take themselves out of the gene pool, or they successfully breed with a new behavior, with a mutation, but it requires trial. They have to do the thing that takes them out of the gene pool or promotes their fecundity. Well, if you can learn by listening to the explanation of another or by observing the behavior of another, this is an enormous evolutionary shortcut, and this is one of the defining characteristics of mankind. And this, in Christakis' explanation, goes along with a suite of what he calls social behaviors. So number one in the social suite is a preference for mild hierarchy. Not the violence-based dominance hierarchies of the animal kingdom, but rather a preference to learn from people who other people are learning from. So it comes back to our hero stories, really. We like heroes. We like to know, we like to make judgments about who should we learn from. And we give kudos to those that we affiliate, that are teaching others. Another one is a preference for homophily. So sometimes we mix with people that are not like us, but mostly the dominant tendency of humans is to mix with people like ourselves. And it's interesting that the word like has this delicious ambiguity. It means I have a preference for your content, but it can also mean I am like you. I'm homophilous to you. And of course, that's where the tribalism of liking comes from. And the currency that we pay for these acts of social learning is recognition. We recognize those that we've learned from. That's the counter on the like button. The thumbs up gesture itself was it was really not hard for the designers in Silicon Valley at the time to reach for the thumbs up symbol, because it was already deeply embedded in American culture. From the fighter pilots of World War II who made their thumbs up gesture to say, ready for takeoff. They couldn't say anything because it was too noisy with the airplane engines, but they all go. To the Fonz. Everybody remember Happy Days? You know, the cool like. If you ask an American, yeah, but where did it come from originally? Many Americans would be convinced that it came from the amphitheaters of ancient Rome. So here you see a painting by Gérôme, a French painting from the 1870s, which was extremely popular with the gentrifying, with the rising American middle class, partly because of an amazing printing technology, a high production, a high quality reproduction technology that was being diffused by Gérôme's father-in-law, Adolphe Goupil. So these prints of classical paintings were very affordable. And one of the collectors of these paintings was actually the Reverend Thomas DeWitt Talmage, who you may or may not have heard of, but is probably the most successful preacher in history. In the later part of the 19th century, he had an audience of 30 million. His sermons, and he often talked about the thumbs up and the thumbs down symbol of the Roman Colosseum, were franchised to about 3,500 newspapers globally. So we think that this is where it came from. And you can see the Vestal Virgins there giving the thumbs down symbol to the fallen gladiator. Very dramatic, very striking. But it wasn't actually true. So the evidence of coins and texts from the period says that the Romans probably had a thumb gesture that served this function, but it was more likely the sheathed thumb for mercy, like sheathing of sword, and the downward pointing thumb for the unsheathed sword, not giving mercy to the fallen gladiator. But of course, in culture, a fiction is a fact if it's widely enough believed. So this becomes hardwired in American culture and receives regular top-ups from popular culture along the way. Ridley Scott made the film Gladiator 1 in the year 2000, precisely when the social media revolution was happening. And he actually went to a meeting where he knew he would be offered the directorship of the film, Gladiator 1, and he was intent on turning down the film because, in his own words, he didn't want to make a togas and sandals movie. But interestingly, he was shown the very same painting, this painting by Jerome, and he was really impressed by the drama of it. So on the spot, he reversed his decision. But why would the designers reach for in a sense, the thumbs up is really nothing to do with the lines of JavaScript code that serve the function of providing instant recognition for a restaurant review or a piece of user-generated content. They were probably also influenced by another idea at the time, which was by a famous web design guru. Web design was just coming to be an art and was very much in demand during the period to make user websites appealing to consumers. And Steve Krug's revolutionary idea, and it's quite a departure from history in a way, was if you want your innovation to spread, and of course people did want their innovation to spread with social media, then actually you should make it not look novel. You should make it look like something that is nothing, that is already there. So the idea is to take all of the friction out of the process. Don't require people to read a manual, press buttons, have to think about, how does this thing work? You piggyback on the evolved psychology of the like button because it's already there, which is probably the reason that we could write a book about the like button, because in a sense, it seems to be nothing. It seems to be so inconsequential because it was designed to be that way. And there never was a manual or a huge marketing budget to promote the like button. We just knew how to use it. Let's ask another naive question. Where did this occur? Did this occur in the Royal Institution or the Cambridge Computer Science Department? No, actually, the ideas around, the technical ideas around the like button were pretty much in the garages of Silicon Valley at the time, and even in the usage of the users. So the innovation was not in an ivory tower. And there's a very important person in the history of the like button called Kevin. And this is the Yelp page of Kevin. And Kevin was doing something very interesting when Yelp was taking off as a company. He was submitting restaurant review after restaurant review. And this was rather strange for a number of reasons. Number one, nobody else was submitting restaurant reviews. Number two, there was no official route in the software to submit multiple restaurant reviews. He'd found a backdoor route, a forgotten route in the software, in order to be able to do this. And thirdly, he was getting no recognition. He was sending his reviews into the ether, and he wasn't doing it to impress his friends because they wouldn't be able to find his review. So the team at Yelp went to see Kevin and tried to figure out, why is Kevin doing exactly what we want him to do and nobody else is? And it turned out that it was fun for him. So the attention had previously been on the consumption side of the business, if you like, focusing on the restaurants in the restaurant reviewing process. So Yelp switched to their attention to the reviewers because that was clearly the harder problem, and thought very hard about how can we make this even more fun for individuals that don't have the willpower of Kevin. That's Jeremy Stoppelman in the middle, the founder of Yelp, who tinkered with this function of JavaScript, the ability to locally compute, make local computations in the browser, a purpose for which the browser, the language was not designed. So actually, we dedicated our book to the makers and tinkerers who will never be recognized by history, because there were many people like this in our story that are not recognized as heroes. And to make things really complicated for Bob and I, there were meetups at the time, like this is from a meetup called Foo Camp, that now would be, in modern parlance, be called an unconference, a self-organizing conference, where people shared their latest cool technology inventions. So there was a lot of imitation, copying, building upon. So it's very difficult to say what came first, who influenced who. So we really get a very different story from the one that we heard about from Sir Humphrey Davy. So if Sir Humphrey Davy's story is about an individual, something which is instantaneous, something which is very rational and intentional, something which took place in an institution, this is almost the opposite, right? This is a community of people, a stepwise process, serendipitous in the sense that people were looking to solve one problem and they inadvertently solved bigger problems, and situated in the sense that it was in the diffusion of the innovation. It was in the garages. It was in the production process. It wasn't R and then D and then S. It was in the fabric of the business itself. And one interesting thing about this is it sort of blurs the line between invention and discovery, because if discovery is uncovering what is there but not yet known, and invention is creating things that are not yet there, at least in the case of the like button, we can see that invention is about discovering what things people have already done that can be built on or imitated or recombined. So there's a social discovery element here. Now, of course, you say, that's just one invention. Many glorious hero stories from the Royal Institution. You've just shown us one story. And even if you believe us, I think we have to prove that this is somewhat typical. So interestingly, we didn't have the machine learning and the computational power to look at questions like this until recently, but this is actually millions of biomedical papers. And in the biomedical world, there's now a standard classification for themes and methods and problems and diseases. So you can actually ask the question, what is this proposal about, this grant proposal, and what is this paper about? And so what this is a comparison of the categories in that typology of the categories of knowledge in the grant proposal, and researchers, of course, have every incentive to sell their grant proposals and everything that might come out of them, versus the categories in the actual papers that resulted from those grants. And you can see in the chart on the left that 70% of the facts, the proposals in the eventual papers were in unintended categories. Now, there's a technical problem, which is how broad should you have your mesh of categories, because if we say the category is one, it's called science, then obviously there'd be 100% intentionality. But if you quite coarsely cluster terminology, diseases and so on, then actually you get a very similar result. So the 75% becomes 60%. But at least in the biomedical world, the majority of the eventual conclusions are in unintended categories. So the idea that a discovery and invention are serendipitous appears to be a little more widespread than the like button. It also appears to be social. The number of names on a paper is increased 3 or 4-fold in recent decades, especially in the big money areas of science, especially in physics. in computer science, machine learning, medicine, where the spend is big. But interestingly, recognition hasn't changed much. In fact, there's some interesting papers that show that while a paper, while putting a second, a third, fourth, fifth, or sixth name on a scientific paper, in a sense is a form of recognition, it actually dilutes recognition. We resort even more to the very simple heuristic that the most famous or accomplished or senior scientist is the name that we associate the invention with. And sometimes this collaborative debt is acknowledged. Think of Isaac Newton saying, whatever I've achieved by standing on the shoulders of giants. But sometimes it's not acknowledged. Often it's not acknowledged, as in the famous case of Rosalind Franklin, who actually did all of the X-ray crystallography work that underpinned the discovery of the structure of the double helix. I mean, she wasn't given, except in recent years, very much credit for that contribution at all. And it's becoming more so. So if you look at all scientific papers, the number of authors per paper in most areas is increasing by several-fold, 3 or 4-fold. And if you look at Nobel Prizes and the papers that resulted in the Nobel Prizes, according to the prize committee, then it varies a little bit by area, but the recognized Nobel Prize winners by paper goes from something like being is relatively constant at about 1.1. But the number of authors associated with the papers, the number of other authors associated with those papers goes from something like 1 to 4.5. So the paper that this is drawn from, it says basically the recognition issue, the sociality of science is being less and less acknowledged, and that is a bottleneck in terms of incentives for science. This is very interesting. So the social structure of these multiplayer collaborations in science, the precise details of the social structure are actually quite important. And so this basically shows that research which crosses disciplines is much more likely to result in breakthrough research. And so what you have here is you have citations in a variety of biological fields, citation decile, so the most highly quoted papers, the breakthrough papers, are to the right of each chart. And then you have, that's the line, and then you have various prizes associated with the outcome, including the Nobel Prize, arranged in the same way. And what you find is that what the authors call content novelty or context novelty basically drives breakthroughs. So context novelty basically is drawing upon another field or publishing or drawing from a publication which is outside the field where the breakthrough is made. So think about DeepMind, an AI company, solving the protein folding problem. Essentially, it crosses fields. Content novelty is using a model from one disease or a method from one disease in another disease. And especially context novelty drives breakthroughs. So this, I think, presents an interesting mystery, which is, so some scientists have said as much, that we don't tell it the way it is necessarily. We like to celebrate the heroes, to simplify the stories. But why? Why, in spite of this growing evidence, do we persist in doing so? This is one of my favorite books by 2 social psychologists, Ross and Nisbet. And so they basically wrote a book called The Person and the Situation. And what they studied basically was, how do we explain things? And what they uncovered was an incredible propensity or bias to want to explain complicated situations in terms of the actors in the situation. So if it's, Bob and I strolling across Regent Park and we bump into this person and it was raining that day and somebody gave us this paper and this person went to school here, we will reduce that complexity by basically eliminating the context and saying, Bob invented the like button, or we like to simplify by focusing on the actors. They showed that in their field, psychology, if you take every known quality of the actors, you're only, in the best situations, able to predict 30% of the human behavior. The context is actually far more predictive, but we prefer not to go into detail on the context. Why? Well, there may be cases where we have de novo innovation. I'm not saying that serendipity is the root of all innovation. So let's try and think of an example. Not many people would dispute that Newton proposed and worked out the details of the inverse square law of gravity. Maybe that's a de novo innovation. Although actually, if you look closely enough, it's very hard to find an example that isn't social. So it turns out that actually Robert Hooke had accused Newton of plagiarism on the inverse square law. And this phrase, standing on the shoulders of giants, was actually taken from a letter to Hooke. And it appears to be a refutation of the accusation. So Hooke was allegedly a short, stooped man. And standing on the shoulders of giants can be interpreted as, if I copied from anyone, it certainly wasn't you. So, maybe even Newton preferred to suppress he was answering the allegation fairly vehemently, so there must have been some substance in the allegation, perhaps. Well, it's a simplification, isn't it? It's a simplification. Maybe we don't all need to know. Maybe when we say Newton invented the inverse square law of gravity, or Einstein invented relativity full stop, maybe this is a good enough heuristic for most of us. And then, of course, there may be some evolutionary survival value in exaggerating our own agency. Sometimes optimistic hypotheses and Bayesian statistics are useful, right? Because if you say, I have no agency, you renounce agency, or virtually no agency. The chances of you actually exercising agency, if you have it, become reduced. So maybe false self-aggrandizement has some survival value for us. So let's come back to our starting story. An apparently simple story. So Humphrey invented this thing and saved the Industrial Revolution. Well, we spent a lot of time going back to the original stories, and it's actually not so simple. So there was William Reed Clanny and Stevenson at the same time with similar inventions, with bitter recriminations of plagiarism between the three. So Davy was especially vociferous. He called Stevenson a petty thief and not a clever one, was one of his accusations. Or an illiterate pirate was in another letter. He called him an illiterate pirate. But the facts appear to be that Stevenson actually tested a successful safety lamp, which was very similar in design to the Davy lamp, before Davy had actually completed his prototype. Clanny, for sure, there's documentary proof that Clanny published and announced a safety lamp design 2 years even before both of them. And to complicate matters, all three of them had many iterations that resulted in a lot of convergence of the invention. And in fact, we celebrate the safety lamp, saving the Industrial Revolution, but in the northeast of England, actually something called the Geordie lamp, which was essentially Stephenson's design, dominated. And some people thought it was a superior design. So maybe even in our clearest hero stories, they're not as clear as they might appear. One of the problems with this hypothesis is that it's not very comforting to think, whether I'm successful or not depends upon serendipity. I place my invention or my company in the hands of fate. So if the serendipity hypothesis were true, would that mean that we are consigned to passivity? Fortunately not. So here's some work from LIMS, the London Institute of Mathematical Sciences, based just upstairs, who looked at both the theory of recombination, So the idea is that inventions are generally created by recombining existing elements, including whole modules of invention from previous rounds of invention. So it's like playing with Lego blocks, except that you return the successful Lego model to the bag. So you can either pick a module or you can pick a Lego block. And then they tested that by looking at a number of fields, gastronomy, software, language, and other fields. And what they found is that the pattern of serendipity and invention in all of these fields follows a pattern. It's not random, it's not predictable at a granular level, but it does follow a pattern enough to be shapeable. So I show this because it's an easy example to understand. This is the number of valid recipes, cooking recipes, that different ingredients appear in. And you can see that the order for many ingredients, the relative order, doesn't change as you increase the complexity of the recipe, the number of ingredients in the recipe as you go from left to right. But there are some crossovers. So if you look at garlic, which is five positions down. So if you're a Russian, you might eat raw garlic, but generally we don't eat raw garlic. In recipes with few ingredients, garlic is not a predominantly important ingredient. Once you start getting into complex recipes, its relative utility rises and you have a crossover in utility. So the beauty of this approach is it sort of combines the incremental patterned innovation approach, in other words, the relativity of the lines, the swim lanes doesn't cross over, with these surprises of serendipity. So this is quite useful, right? Because this tells us if your field has a lot of crossovers, which is something you can measure, then probably you should be more patient because the apparent utility of an ingredient in your invention could increase or decrease over time. Here's an even clearer example of the influenceability of serendipity. So this is the number of valid recipes in a small kitchen, 127 ingredients, versus a larger kitchen, one which is 3 times larger that has more than 300 ingredients. And you can see that for a 3-fold increase in ingredients, the number of valid recipes increases something like 90-fold. So this is a variable that we can influence, right? Which is how much diversity of, what is the diversity of elements or ideas that we put into our innovation process? We can influence the innovation process in that way. Now, one of the things I love about working with LIMS is it not only is studying the mathematics of innovation, but actually is very interested, it is passionate about putting its findings into practice. In other words, it's a managerial innovator. And as an example of that, the paper that I just quoted from was published at the same time as a practitioner article, a Sloan Management Review article of the same content, because LIMS wanted to challenge the idea that the applied necessarily follows, by a long space of time, the pure. So they set out to write a paper which was scientifically novel and useful to practitioners at the same time. And it was off by a few months, but it more or less succeeded. So that combination of managerial and scientific innovation, I think, is very exciting. Now, we're at the RI, so we couldn't really allow the evening to pass without a stunning demonstration. So, so what we have is, yes, please do, thank you, Charlotte. So what we have is 3 beakers of peroxide, and peroxide is essentially water with an additional oxygen, and it can spontaneously decompose. So two molecules of peroxide can bump into each other and produce 2 molecules of water and 1 molecule of oxygen. And we're going to ask the question, can we, by shaping the context, change the productivity of the reaction? And of course, chemistry is stochastic. Molecules only react if they bump into each other with the right energy and the right orientation. And in the number 1 beaker, we have dilute peroxide, about 10%, And you can see not much is happening. No innovation, unsuccessful lab. Grant just withdrawn by the administration. In the second beaker, we're going to add a small quantity of a catalyst, manganese dioxide, which doesn't form manganese compounds or anything. It lowers the activation energy for the reaction. And I'm not sure whether you can see at the back, but you can see there's some gentle bubbling there. So that paper probably was published in Nature. There's some production function there. But of course, we can also supply heat, and we can increase the concentration of the peroxide and increase the amount of the catalyst. And this is where the Nobel Prize comes in, I think. So this is shaping the context. And my remaining question, I can't actually see the time. Am I doing on time? So thank you very much, Michael. By the way, these guys just won a prize from the Royal Society for their demonstrations, and they absolutely deserve it, and I'm very happy about that, because they describe themselves as the home of science. Science lives here, but actually, in truth, the genius is in the communication and the promotion of science, and demonstrations, I think, are a very, very big part of that. So the remaining question I'd like to address is, can we, the clock's come back. So very, very quickly, so that we get you out here on time, I'd like to visit the question, could we manipulate the social context of innovation, the way that we manage our laboratories, in order to increase the productivity of innovation, if the serendipitous model were valid? Well, I think we can, and I'm going to quickly give you some examples from business and from science too. We can increase the number of collisions. So my own company employed a spin-off from MIT called Humanize, and they have badges that measure who is in proximity to who, and who is facing and talking to whom. And we knew from our analysis of how ideas evolve in our business that big meetings don't result in new ideas, and good morning doesn't result in new ideas. But 8-minute collisions, what are you working on? Oh, that's interesting. Have you tried this? That results in new ideas. And so we basically designed a new office using this experimental data. And we found that we were able, by increasing the public spaces and decreasing the private spaces, and also not having completely private spaces, the ownership of the private spaces rotated, that we could increase the number of collisions. And that's something that LIMS tried to do using the ancient technology of blackboards, mathematicians gathering around blackboards to swap ideas. We can increase variety. The paper I showed you on the diversity of ideas was from a journal called the Research Policy Journal. Why a policy journal publishing this? It's because, of course, it has, this model, this question has a huge impact on how you allocate scientific funding. If you believe that science is very intentional, you don't want to waste money by sprinkling resources into cross-disciplinary initiatives. You want to give the cardiac innovation to the cardiologists in the Cardiology Institute and tell them what you want. If you believe that innovation is more serendipitous and that it benefits from crossing fields, then you fund cross-disciplinary research and you tolerate a certain amount of inefficiency for the purpose of high productivity. The prepared mind. There were several interesting events to do with library organization in the 1980s, where the Anglo-American library classification scheme changed, which resulted in journals swapping their relative positions, which exposed researchers to journals they didn't usually read. And what they found was that some scientists increased their quotations from and probability of breakthrough work as a result of this reorganization. And the number's about 7%. There was a 7% uplift. The interesting thing is there was a 0% uplift for those scientists which basically never quoted outside their discipline. So in other words, it's something to do with not just the exposure to a variety of ideas, but the propensity to embrace that variety. I'm going a little quickly because I want to stick to time, but I'm happy to go into further depth in the Q&A. If you find something, whether it's in a laboratory or a company, usually if that thing is significant, it involves changing something. You've got to change how resources are allocated. If you have a breakthrough project, then presumably you want to invest more in that project. You may have to do different things. You may want to change the way you organize to the more successful way of organizing. And that, of course, organizations are not very good at. So flexibility, evolvability is very important, but so is efficiency. So one idea that some companies, and which LIMS has experimented with, is the idea of evolvable scripts. So script is not a standard operating procedure. A script is like an acting script. It's designed to inform the actors how to write a grant proposal, how to write a scientific paper, how to raise funding, and to align people on the currently agreed most successful approach. But the scripts are evolvable. They're occasionally revisited in the light of experience. And therefore, the evolvable script gives you this trade-off, balances the trade-off between efficiency and evolvability. You're able to change things if you find a more successful way of doing things. And it is actually one of the secrets behind the most productive retail format on earth, which is the Apple Store that precisely implements evolvable scripts to standardize but also evolve how it approaches and deals with customers. And then lastly, you can shape the economics of innovation. So there's a certain intrinsic inefficiency of combining different fields to see what will happen, carrying out experiments, trying new ideas. And it almost seems inevitable, right? Which is the experiment will not pay off immediately. It seems reasonable. Many of the experiments will fail. It seems reasonable. And it will cost something. You have to employ a researcher to do the experiments and the overhead costs. But actually, in the digital world, we don't necessarily have to take these trade-offs for granted. So we've been experimenting with an idea we call co-ambidexterity, which is the idea that if you design your business model correctly, you can actually get paid for exploring. So the idea is that every company explores new ideas and exploits its existing business model, but so does every consumer. They may want to buy such and such a product now, but there's a deeper journey. There's an exploration to improve their life in some way. And if you can get paid not only for the transaction, satisfying the immediate need, but for facilitating the consumer's journey of exploration, so you don't just sell them the dumbbell, you sell them the fitness education or the fitness experience, you can actually get paid for exploring and break this traditionally assumed trade-off. So let me stop there. Thank you for your attention. I'd be very happy to take any questions or comments you may have.